Hello everybody, this is Mrs. Snook with section 4.5. We're going to do 4.5 over 2 days, and today we are going to graph the sine function. And our objective is to sketch graphs of basic sine functions, and we're going to do both the basic one and one with transformations. So first off, you can think of y equals sine of theta as a parent function. And I want to show you what that graph looks like. So let's do an xy table, or in this case, theta y table. And I'm going to pick 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then if you look on the tables in your book, the values at these points are 0, 1, 0, -1, and 0. So then if I go to sketch this graph, I'm going to put 1 here, I'm going to put -1 here. I'm going to have a point here, 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 and here. And now all I have to do is sketch the curve. Now make it smooth. So up, I hit my maximum. Now I'm going to turn, go back down to midline, back to the minimum, and back up to the max. Try to make that smooth as you can. And then I want to show you sort of the general form of a trig function. And that is y equals a sine b of theta minus c plus d. So that means you can use a, b, c, and d for transformations. Now there's some terms I'm going to be using in this video that I would like to define. First of all is period. So the sine graph just keeps repeating. I could go further and this would go up and then back down. Over on the other side it would keep going down and then would turn around and go back up. And one complete cycle of this graph is called the period. So it's going to start at 0, go up to max, back down to the midline, down to the minimum, and then up to the midline. And that's considered one complete period. After that, it just repeats itself. And with the transformations, we can actually change that period. And the formula we're going to use is 2 pi over b. So the amount of time it's going to take to complete one period is just going to be 2 pi over whatever that b is. The next idea is the amplitude, and that's the distance from the midline to the height. So right here, our midline is right here, and then the amplitude is how far you go up to get the maximum. It's also how far down you go. So this is also amplitude. Next idea is the phase shift. That's a left-right shift that we're already used to. And you get that from C. And so if you look at this dashed graph, that's our original parent function. And I've just highlighted one cycle. If I was to shift that over to the right, we then can have a graph that looks like this. This is shifted over to the right. So right in there would be your phase shift. It's how far you're shifting it. And just like in our previous functions, you're going to have to change the sign on C. So if you have a minus pi, say minus pi, that's going to be a shift to the left. And if you have a plus pi, that's going to shift to the right. I think I said that backwards. Plus pi goes to the left, minus pi goes to the right. And then the other idea is your vertical shift. Now we're used to that, up and down. And that's going to be from D. It's going to cause a vertical shift where your sine wave goes up or goes down. And the easiest way to think of that is it's actually shifting where your center line is. So if I start with this dashed one again as the period, right here on the x-axis is your center line. But if I have a vertical shift, which gives me the solid one that I'm highlighting in green, then basically that center line is just going to shift. So now right here, I'm going to do this in red. That's our new center line. And that's D. And if D is plus, you're going to shift your center line up. If D is minus, you're going to shift it down. Next thing is the idea of the starting value. Since these graphs all look the same, we can very easily put in these transformations just by changing the scale. And so to do that, I can change my starting value. So instead of starting at the origin, right here, if I have a shift, I can then start instead at the origin. Maybe I'm starting at pi over 2. So I might label this point, instead of calling it 0 for the origin, I might call it pi over 2. And that would take care of the shift for me. So let's go ahead and we're going to graph one of these. We're going to sketch one cycle of the graph y equals 3 times the sine of 2 times theta minus pi plus 1. So first thing I want you to do is figure out A, B, C, and D. Well, here's A. A is 3. B is 2. Here's C, which is pi, and here's D. So A equals 3, B equals 2, C equals pi. Remember, change that sign because it's a horizontal shift, and D equals 1. All right, now I'm going to come in and I'm going to set up my scale. My top line is going to be at D plus absolute value of A. So I get 1 plus 3, that equals 4. So this top line is going to be at 4. My center line is going to be at D, so my center line is at 1. And then my bottom line is at D minus absolute value of A. So 1 minus 3, so I get a negative 2. So that's going to be my vertical scale. So think of that as your y-axis. And if you want to, there's your x-axis. Okay. Now let's figure out our period. We're going to do 2 pi over b. So 2 pi over b is 2 pi over 2. That equals pi. So one period all the way out right here is pi. No, that doesn't look good. So that point right there is pi. My starting value c. C equals pi. So therefore, my starting value is going to be pi. So let's go ahead. I'm going to call this point pi. So that means one whole period out is going to be 2 pi. So that's going to be 1 pi wide. Now I'm going to write my critical values. So that's going to be every quarter cycle, you're going to have a critical point. And these are going to be on your center line and your mins and your maxes. And you're going to have 5 of them total. The first one is where you start your graph. So for me, that's going to be right there. We'll start on the center line. The quarter point, I'm going to take my critical point, which was pi, and I'm going to add a quarter period. And a quarter of that period is just another quarter pi. So I'm going to have a critical point at 5 pi over 4. And then my halfway point, I'm going to take that pi and I'm going to add half of a period. So I'm going to add pi plus half pi. So that gives me 3 pi over 2. So then if I go halfway, I'm just kind of eyeballing halfway across. this would be 3 pi over 2. Then that makes the quarter point right here at 5 pi over 4. And then my 3/4 point, I'm going to take my starting point pi, and I'm going to add 3/4 of my period. So I'm going to do pi plus 3 pi over 4, which gives me 7 pi over 4. So right here is 7 pi over 4. And then my end point, that's where I've completed a complete cycle. So I'm going to take my c, which is pi. I'm going to add period, which is also pi. So pi plus pi gives me 2 pi. So now I've got my graph kind of sectioned off. And you can think of it as, here's my first section. Here's my second section. Here's the next one. And here's the last one. And I'm just going to go ahead and I'm going to use these values and I'm going to plot my graph. Sine graph always starts at your starting point and on the midline, which is going to be right here at 1. I'm then going to go up to the max, which is right there. Just go to the first critical point and to your top line. I'm then going to go to my next critical point, back down to the midline, which is right here. Just a reminder, this is your midline, not your axis. And then I'm going to go one more quarter cycle to my next critical point. That's going to be a minimum. And then I'm going to go back to midline. So here's what my graph looks like. Up, down, down, back up. There's one cycle. Okay, let's do this again. This time, A equals -3, B equals 1, C equals -pi. Remember, change that sign. And D equals -5. So let's go ahead and just label our axis. Top line is D plus absolute value of A. So D is -5 plus 3, that equals -2. So right there I have -2 for that. My center line is just D, which is -5. So this is -5. My bottom line is going to be D minus absolute value of A. So -5 minus 3 equals -8. So here we are, -8. And just remember, this is our midline, not the axis. Period, 2 pi over B. So 2 pi over 1 equals 2 pi. And my starting value is C, and that's -pi. So right here is going to be -pi. Now my critical points. I'm going to add C -pi plus a quarter period each time. So -pi plus 2 pi over 4 is going to be -pi plus pi over 2, so -pi over 2, and then -pi plus half a period plus pi, so that's going to be 0, and then -pi plus 3/4 of a period plus 3 over 4 times 2 pi is going to be -pi plus 3 pi over 2, which gives me pi over 2. And then my endpoint is going to be -pi plus a whole period plus 2 pi, and that equals pi. So I'm going to come over here. I'm just going to label. I'm just going to use my midline as a place to label these. And halfway through, that's going to be 0. And then a quarter of the way, -pi over 2. And then over here is +pi over 2. So now I've got my graph sectioned and I am ready to sketch. Now here's one thing to watch out for. A is negative. So instead of starting at 0 and going up, I have a flip. So I'm going to start at my midline and I'm going to go down. So I'm going to have a point here. Then I'm going to go back to midline, and then I'm going to go up. So here's what this one looks like. Okay. So your assignment is on Delta Math. So let's do some of these on Delta Math so you can see how that's going to work. So what I've done is I've copied the Delta Math problem so I have a place to do my work. So on this one, A equals 3, B equals 1, C equals 0, and D equals 0. So what that means is my top line is going to be up here. I'm just going to call this 3. So right here is going to be my top line. And then my bottom line is going to be here at -3. So this here is our midline. Let's get our period. So that's just 2 pi. So on my graph, for my x-axis label, I'm just going to put in 2 pi. Okay? And then what I'm going to do is plot some points. I'm going to plot my critical points. Okay? My first one is my starting point. That's at C, so that's going to be at 0. And then my quarter point is going to be 0 plus 1/4 of a cycle. So pi over 2. Then my halfway point is going to be 0 plus half a cycle. My 3/4 point is going to be 0 plus 3 pi over 2, which equals 3 pi over 2. And then my end point, my last one, is going to be 0 plus 2 pi. That's a whole cycle, or 2 pi. So when I go to graph this, and I'm just going to pick, so this one will be pi over 2. I'm just going 3 blocks each time. Okay, and so my graph is going to look something like this. I'm going to start at 0. I'm going to go up to 3. I'm going to come back to 0 because that's the midline. I'm going to go down to 3, and then I'm going to go back here. Now the neat thing about Delta Math is it's going to do the graph for you. You just have to tell it the scale. And I'm going to go ahead, when I go to Delta Math, I'm just going to put 1 in the scale for the y-axis. I'm going to put 2 pi in the scale for the x-axis. So now I'm going to switch over to Delta Math. And I'm going to show you how to enter this. So I'm going to put 1 for that one. And our period was 2. And I'm going to click on that pi to get 2 pi. And then I just say done. No, that did not work for me. It was supposed to show me the scale on the axis. So 1 goes there, 2 times pi goes there, say done. Okay, now I've got my scale. And I'm going to go ahead and I'm going to plot my points. I'm going to do my first point, we said was at 0, so I'm going to have a point here. And then I said I would go 3 blocks, so 1, 2, 3, I get a point there, 1, 2, 3 there, 1, 2, 3 there, and then 1, 2, 3 there. And now I'm going to actually plot these points on their location. The first one we said was going to be at 0, 3, so I'm going to take that one and I'm going to move it up. So we went from 0 up to the max. We're going back down to the midline. Now I need to go down to the min, which is right there, and then back to the midline. So you see how it's did the graph for me? And the other thing I need to do is make sure that I slide this one. It's got to be at the same place. It has to be at 2 pi so that my period is correct. All right, think I'm ready to submit my answer? And see, we got it. All right, that's it for today's video. Have yourself a great day, and thank you for watching.